Bonjour. I do not have any slides. I'm a person who likes to just do a lot of talking. And I want to build on what Stefan just talked about because it really sets the stage for the way that I view innovation. And innovation in an organization is really, it's not even so much about new products or new processes or new business models. It's about adaptability. Organizations these days need to move at a faster pace because the mantra is that when the pace of change outside the organization is faster than the pace of change inside the organization is going to be out of business. And so the question is, how do you build a business that is able to adapt, evolve repeatedly and rapidly? Now, when it comes to open innovation, that is trying to come up with new solutions to help push the organization forward, there are two prevailing approaches that are used. One is what I would call asking for suggestions. We think about the suggestion box, and this is one which is used quite often. If you think about a lot of organizations out there, they will ask their employees, what's an idea you have? Give me something that you think will help improve the organization. We also see that a lot of organizations give their employees a certain percentage of time to work on the development of new ideas. Here's the problem. Companies do not have a shortage of ideas. They do not have a shortage of ideas. They have a shortage of good ideas that actually are going to help move the company forward that ultimately can be commercialized and create value for the organization. So when we look at most organizations and they have an idea-driven innovation model, what I would suggest is that we want to change that. We want to change that to what I would call a challenge-driven innovation. We don't want suggestions, we want solutions. We don't want ideas, we want actually specific, tangible things that we can go implement. Let me give you a couple of very simple examples of this in action and why it's important. If you've been watching the news, we had a bit of a disaster in the U.S. a number of months ago in the Gulf Coast. I'm sure you're all aware about the BP oil spill. So BP, in their effort to try to stop the well from spewing more oil, they decided that they would use open innovation. They created a website, and they basically asked the question, how do we stop this? They received, I don't even know what the final number was, but when I looked at one point, they had roughly 80,000 suggestions. They had a team of people who were dedicated full-time trying to evaluate them. They could only get through 20,000. Of those 20,000, what percentage, how many of those 20,000 do you think had any merit or value at all? Any guesses? 2%. That's a little optimistic. It was actually 100 of those suggestions, which is about 0.5% if my math is correct. Now, if you think about it, one of the least used measures in innovation, but I think is one of the most important measures, is what I would call the signal-to-noise ratio. The signal-to-noise ratio is basically the ratio between what you want and what you don't want. So if you're into music, for example, the signal is the music, it's the sound. The noise is the hiss or the background. While in innovation, the signal are the ideas that you can actually use versus the noise, which are all of the things that clog up the system. And the way we tend to do open innovation has an extremely low signal-to-noise ratio because we ask such broad questions or we ask for ideas and we get lots of input of which very little of it is useful. And so we have to spend a lot of time trying to process through all of the different suggestions that were provided. And I always ask a question, it's very interesting when I work with organizations and we look at measures for innovation. If we have a problem that we're working on, the question that I always like to ask is, what would you rather get? 100 suggestions, of which 2 of them are really good, or just 2, of which both of them are really good? Now, most companies, when they measure their innovation activity, their open innovation activity, actually looking for the amount of activity. The contributions. We want lots of contributions. We want lots of people participating, and the problem is that creates a lot of noise in the system. So what we want instead is, if we use a challenge-driven approach, we want to define the challenge, frame the challenge in the right way that it actually becomes a self-vetting process. And what I mean by that is when we ask the question, first of all, we're asking a question that we know if we get a solution, it will create value for the organization, but also at the same time, we know that people will stop submitting solutions that don't meet our criteria. So it actually helps focus people on what's going to matter most to the organization. And if I were to contrast the oil spill in the Gulf Coast with some work we did a few years ago trying to clean up the Exxon Valdez oil spill. So this is now 20 years ago, so maybe you aren't as familiar with it, but 20 years ago in Prince William Sound in Alaska, the Exxon Valdez crashed, spilled 10.8 million gallons of crude oil, and they've been spending the past 20 years, still trying to clean up the oil. And they had every oil and gas expert on the planet trying to clean up this spill. Well, there's one pressing challenge that they were not able to solve, and the issue was, unlike the Gulf Coast where the waters are warm, the waters in Alaska are extremely cold, in fact, close to freezing temperature. And the crude oil in this cold water becomes really, really dense, and every time they tried to move it, it would actually seem as though it's freezing. So when we looked at the problem, what we realized is it's not about oil and gas, it's not about freezing oil, but in fact it's a very technical thing called viscous shearing. And essentially what viscous shearing is when you take a really dense liquid and put it under kind of force or acceleration, it takes on the attributes of a solid. So we asked our community, how do we solve a viscous shearing challenge? How do we prevent a very dense liquid that is moved from acting like a solid? Now, we didn't get tens of thousands of solutions. In fact, we got a very few number of solutions, but we got one solution that actually solved the problem that oil and gas experts have been working on for 20 years. I'll give you the solution at the end. Because I want to talk about a couple of other things that I think are very relevant as it relates to open innovation. The whole point is that when we ask better questions, we will get fewer solutions, but we will get better solutions, and we will know that those solutions will create value for the organization. Now, this to me is very important, and I always like to use a quote from Albert Einstein, because I think this is probably one of the most insightful quotes I've ever heard. It's attributed to him. I'm not sure he actually said it verbatim. But essentially he said that if I had an hour to save the world, I'd spend 59 minutes defining the problem, 1 minute finding solutions. 59 minutes defining the problem, 1 minute finding solutions. And from my experience in working with organizations, most companies spend 60 minutes of their time finding solutions to problems that just don't matter. So when we really get masterful at defining the problems, we sometimes will find solutions that pop to the surface and become more obvious. Now, the reason why this is important and why open innovation and open source is important, but open innovation in particular, is because the biggest breakthroughs tend not to come from the domain of expertise and where we're trying to solve the problem. It is really about diversity. So if my first point is we want to focus on challenges, not ideas, my second point is I want us to focus on diverse points of view rather than homogeneous points of view. And the problem is most organizations hire people who think the same way. They're designed for everybody to speak the same language. They speak the same jargon. They have the same acronyms that they use. So what we end up inside of organizations are people who think the same way. Now, I'm not sure how this is going to translate, but essentially what we've done is we've created organizations that are cults. We call it a culture. We want to create a culture. And we have a strong culture, but the problem is cults are a form of culture because what we've done is we've created homogeneous thinking. So if we want to be able to be innovative, we can't think inside of a cult. Homogeneity is very good because it's efficient. When everybody speaks the same way, thinks the same way, talks the same way, we can get things done very quickly. But innovation, divergent points of view, is really how we come at it. So what we need to do is think about how do we bring these divergent points of view. Now, let me give you just some very interesting examples of problems that have been out there that got solved from some very interesting points of view. So let's come back, for example, to the Exxon Valdez oil spill. The Exxon Valdez oil spill, an oil spill challenge. Dense liquid that turns into a solid when it's moved. We posed the challenge. Within a matter of weeks, we got a solution from someone in the construction industry. Someone in the construction industry recognized the fact that when he's pouring cement, he had the same exact issue because cement is a dense liquid, and if it was moved too quickly, it would actually clog up the machines. And so he developed this radio frequency device, this vibration device, that would move the molecules in such a way that it would prevent the viscous shearing and prevent it from solidifying. So the cleanup crew in Alaska took this invention, brought it to Alaska, and they found that it worked. Now, the cool part about this story is the guy who found the solution, the guy from the construction industry, took his $20,000 award and spent it on airplane tickets and went to Alaska and helped the cleanup crew. So a solution a lot of times will come from a different domain of expertise. One of my favorite ones is actually a potato chip manufacturer. A potato chip manufacturer wanted to find a way to reduce the fat in their potato chips without impacting the flavor. And the way that they had always done it in the past, or attempted to do it in the past, was they would deep fry the potato chips, put them on a conveyor belt, they would vibrate the conveyor belt to shake off the oil, and then when it gets to the end, they would put the chips in the bag. The problem is, by the time the chips got to the end of the conveyor belt, they were crumbs. So the question was, how do we be able to reduce the fat in a potato chip? How do we vibrate it in a way that will not break the potato chip? So this is a solution that came not from a food engineer. It didn't even come from an engineer. It actually came from a musician. So a musician recognized the fact that when he was listening to music, he could feel the bones in his head vibrate. So he went home one night and created a makeshift potato chip manufacturing plant, and he put a loudspeaker over it and tried different frequencies, and he could actually see the fat falling off of the potato chips without it breaking the potato chips. Fantastic solution. We would have never thought to ask a musician to come up with an idea for reducing the fat in potato chips. I mean, this is about connections. And sometimes asking better questions will force you to get better solutions. This is one which I really like, which comes from a toothpaste manufacturer. A toothpaste manufacturer wanted to find a better way to whiten teeth. Now, if you think about the way we typically whiten teeth, there's two ways that are used. One is we either use an abrasive, which removes the enamel from the teeth, or use a bleach, which is dangerous to the gums. So they wanted to find a way of whitening teeth that would not be abrasive or would not use a bleach. Now, this is a big multinational, and they found the solution inside the company. So they didn't have to go external. Open doesn't necessarily mean go to the world. They actually found a solution not in their dental division where the toothpaste is done, but they actually found a solution. Well, think about it for a second. I mean, the question is, who makes whites whiter? I mean, our teeth are white, and we want to make them whiter. Who's the master at making whites whiter? Well, what they realized very quickly was their laundry detergent division had been making whites whiter for 20 years. And the ingredient that's used in most laundry detergents to whiten your clothes is actually a bluing agent. So when we look at our white clothes and we wash them, they're actually not white. It's an optical illusion. In fact, our clothes are blue, but because since the air is blue, it actually appears white because we can't see it. And so what they did was they tried putting, and they created a product, a toothpaste, that has a bluing agent inside the toothpaste, which will instantly whiten your teeth, at least as an optical illusion. So your teeth appear whiter, even though they might be totally yellow. So it's a very interesting thing when we start trying to connect the dots. So I had a quote from Einstein. I'll give you a quote from Steve Jobs, because I really do think that this is, to me, the essence of creative thinking. Steve Jobs from Apple once said that creativity is just having enough dots to connect. Creativity is just having enough dots to connect. Dots being ideas or experiences. And the reason why creative people are so is they've either had more experiences or they've thought more about their experiences. So creative people are naturally focused on connecting the dots, and when we start using things like open innovation, we can actually formalize that process to connect to people we would not normally be able to connect to. When we issue challenges to the world, there are three primary ways of finding solutions. The first way, and this is sort of the traditional way that we tend to find solutions using open innovation, is we look for a solution provider. So what we'll do is we'll say, we have this problem, we're working on this challenge, we want to find a solution, and we will then either issue a request for proposal, or we'll partner with a university, or we will find another company that we can partner with that will help develop a solution. But we're not buying a solution, we're providing a solution provider. The second model is sort of instead of looking for a solution provider, we're looking for a solution. And a lot of companies use this when they do things like tech scouting. So what they will do is they say, we have a problem, let's find somebody out there who already has the solution. We'll go do patent searches, and we'll look in other different types of databases, and we'll find people who might be able to provide a solution to us. So that's a single source solution. And the model that I tend to focus on, and the model that InnoCentive uses, is sort of a crowdsource solution. When you ask a question, you get a solution. And I'll use one last quote and wrap it up. And it's a quote from Edison. And Edison, Edison is the one that everybody in the R&D organization loves to quote because it justifies the way that we've done R&D work since the beginning of time. And basically, Edison reputedly said, while trying to invent the light bulb, he said, I didn't fail 700 times. I didn't even fail once. I found 700 ways that didn't work, and that was useful because once I eliminated those 700 ways, I was able to find the way that did work. Therefore, he's saying that they weren't failures. And I say that is baloney. Because had Edison actually found a solution to the light bulb on the first try, there is no way he would have continued to fail 700 times in the name of learning. So what we want to do is actually think through how can we get to the solution as quickly as possible without failing. And ideally without failing on our time. So if I'm an organization, one of the things which I like to do is if I issue a challenge, I like to think of it as a massive parallel process where instead of all the failures happening in series, in sequence, they happen in parallel. And I can have thousands of people working on a problem at the same time, of which maybe only one or two of those will work, but that's the one that we actually want. So it's a massive parallel process of successes and failures where you pay for the successes in terms of time and money. You can solve a problem in 2 weeks that was taking 20 years in the case of the Exxon Valdez. And this is independent of what platform you use. It's just the philosophy of parallel processing, time-based, as a way of driving faster innovation. I'll close with just a quick story from NASA and then a quote. And NASA, is interesting. One of the things that they've been working on since the beginning of flight is how do they predict solar flares? They've not been able to predict solar flares. And the issue is if they can't understand solar activity, they run into a problem because it puts the crew at risk, it puts the equipment at risk. So they've been working on this and hadn't been able to find a solution. Well, they posted the challenge, and within a matter of weeks, there were 4 solutions. Now, you might say that's not really a lot of solutions, but in fact, what was great is one of those solutions was the solution. This was the holy grail. This was the thing which actually told NASA how to predict solar flare activity. And it came from somebody who was a retired mobile phone operator. This was somebody who was looking at dropped mobile phone calls and trying to understand why phone calls were dropped, and he inadvertently stumbled across the formula for predicting solar flare activity. So we can't predict where the problems are going to be solved. They can be solved by a musician. They can be solved by a mobile phone operator. They can be solved by somebody in the laundry detergent division. It doesn't matter. So when I speak at NASA, which I've done several times now, I always like to just leave them with this quote because I think it's a very useful thing. And it's basically that when they're working on their aerospace engineering challenges, if they have 100 aerospace engineers working on the problem, adding the 101st aerospace engineer is not going to make that much of a difference. But if you add a nanotechnologist, a biologist, a musician, then you're going to get some of the breakthrough ideas. So when you focus on challenges and parallel processing and look for solutions in a diverse set of organizations, that's when you start innovating and get new ideas. Merci beaucoup.